welcome to my page. This is Oasis Online Math. We are going to be solving a problem that involves cone, and the question goes thus. The cone is exactly half filled of water by volume. It is half full by water in terms of volume. How deep is the red shaded part? This red shaded part, how deep it is. How deep it is logically is talking about the height of this red shaded part. And also we should know that for the fact that we are told that it is half full of water, doesn't mean the height of this cone, of this, smaller shape here, this smaller region, that doesn't mean it will be the half of this 16. No. So take note of that. Let's dive into the solution one after the other. Whenever we have this type of problem, we should know and we should always consider this problem as a problem of two cones. That is, this is one cone and this is another cone. The liquid inside, or the water, the red water inside, is also forming a cone. So we must consider this problem as problem of two cones. And these two cones, they are similar. They are similar in the sense that inside one, we can find the other, and they share same angle. Of course, this is the angle that they share. Whenever we have two cones similar like this, we should consider something. We should represent each of the parameter of the different cones. They are different cones now, of course, different sizes, but they are similar. So let's talk about the big cone first. The big cone, consider the big cone now. The radius of the big cone, let's denote them. Let's use R, capital letter R. And the height, let's use capital letter H. But for the small cone, for the radius, let's use our normal R, and for the height, then we use the normal H, small letter H that we have. Then when two cones are similar like this relationship hold any day, anytime. And what is that? The ratio of their radius, of their radii rather. This is radius of the smaller one and the radius of the smaller one, of the bigger one. Their ratio will be equal to the ratio of the smaller height and that of the bigger height. What do I mean? I mean radius of the smaller cone over radius of the bigger cone is going to be equal to height of the smaller cone over height of the bigger cone. Height of the smaller cone over height of the bigger cone. Please take note of this. This is small. This should also be small. This is big. This should also be big. So hence, this is the relationship which we have established here is what we are going to use. By substituting the value, we can see that our R, which is we are not given, over capital R, that is the radius of the bigger cone. So we are given the diameter to be 12. So definitely the radius will be 6h. So we put our 6 here, and our height of the smaller cone is also unknown, which is what we are looking for. H over, and the height of the bigger cone, 16. We put 16 here. So let's express this such that it will give us equation in terms of h. So I can say to take this 6 to multiply this. Okay, I will have R to be equal to 6h over 16. If I have 6h over 16, then I can reduce that. 3 here, that's 2 here, that's 3. 2 here, that's h. So R is expressed as 3h over 8. So this equation will be used in solving this problem. And let's see the other information given to us. We are told that the cone is exactly half full of water by volume. Half full of water by volume. It means the volume of this smaller cone to get the volume of the bigger cone will be 2 times of this smaller cone. Or we say the volume of this bigger cone, the half of it will give us the volume of the smaller cone. So let's put it into a notation. That is volume of small cone. It can be half of the volume of big cone. So, and the volume of cone is 1/3 of volume of cylinder. And volume of cylinder is pi r square h. So we have used small r here, which is radius of the small cone, and small h here, height of the small cone, which is going to be equal to 1 over 2. Don't forget, 1 over 2 here is constant, and the volume of big cone will also be 1 over 3 of pi r square, which is radius of the big cone, and h, which is the height of the big cone. So let's solve this one after the other. We have 1 over 3. Our constant pi is there. The radius, which we are not given, and height we are not given as well. And the radius has been expressed as 3h over 8. So I can put it there, substitute it, 3h over 8 all square. Still multiply by h, I mean this h. So it's going to be equal to, if we open this with 1 over 2, we have 1 over 6, 1 over 6, then pi, and the radius of the big cone, which is r, big R, yes, radius is 6, and 6 square will give us 36. Likewise, the h, the height is 16, so multiply by 16. So from both sides, we can see that this can take care of this. So we have 1 over 3, then 3h all square will give us 9h square over 8 square will also be 64 by h is equal to, we can reduce this from here, 6 here 1 and 6 here 6. So on our left hand side we shall have 6 multiplied by 16 left. So on our left hand side we can reduce this as 3 here 1, 3 here 3. So we have 3h square, 3h square dot h over 64. And on our right hand side, which is 16 times 6, which is giving us 96. Okay, so our left hand side here, h square times h, that will give us h cube. So we have 3h cube is equal to 96. We can cross multiply, taking this to this side, that's 64 times 96. And 64 times 96 will give us 6144. So we have 3h cube is equal to 6144. So by so doing, we divide both sides by 3. So dividing both sides by 3, we have our h here will be h cube is 3 in 6144. We have 2048. So obtaining the cube root of both sides, h cube, the cube root, and the cube root of 2048. The cube root of 2048 is 12.699 and so on and so forth. So apparently in 2 decimal places, our final value for h is going to be 16.70 centimeter, which is the height of the red shaded part in the question. Thank you very much, and bye for now.